the second law of thermodynamics, which explains the direction in which natural processes occur. While the first law tells us that energy is conserved, the second law tells us how that energy flows. In simple terms, it introduces the concept of entropy, which is a measure of disorder or randomness in a system. The second law can be stated in different ways. One common statement is heat cannot on its own flow from a colder body to a hotter body. In other words, heat naturally flows from a region of higher temperature to a region of lower temperature. Another important statement is, it is impossible to convert all the heat energy into work without any loss. This means that no machine can be 100% efficient. Mathematically, the change in entropy is expressed as delta S equals Q over T. Here, delta S is the change in entropy, Q is the heat transferred, and T is the absolute temperature. This equation shows that when heat is added to a system, its entropy increases. As a result, natural processes tend to move towards a state of maximum entropy or maximum disorder. Let us take a simple example. Imagine a hot cup of tea kept in a room. Over time, the tea cools down, and its temperature becomes equal to the surroundings. Heat flows from the hot tea to the cooler air. However, the reverse process, the tea becoming hotter on its own, never happens. This is the second law in action. Another example is mixing. If you mix two gases, they spread out and mix completely. They do not spontaneously separate again. This is because the mixed state has higher entropy. To summarize, the second law of thermodynamics tells us that natural processes have a preferred direction and that entropy of an isolated system always increases or remains constant.